friends, already we discussed about the propagation of a wave or the traveling of sinusoidal or longitudinal wave in different medium. We had the equation of the wave speed. Now, what's happened? If the two or more than two waves are superposed or traveling in the same medium, during the moving of these two waves in the same medium, they are superposed on each other. The point at which these two waves are superposed. Now, what is the resultant displacement of this point? So, that can be explained by the superposition principle. So, what is the statement of the superposition principle? When a point of a medium comes under the influence of two or more than two waves, the resultant displacement of this point is the vector sum of displacement of individual waves. Now, the statement of superposition principle is that superposition principle when a point of a medium comes under the influence of two or more waves, its net resultant displacement is the vector sum of displacement of individual waves. This statement is known as superposition principle. Again, repeat it. When a point of a medium comes under the influence of two or more waves, its net resultant displacement, that means the resultant displacement of the point, is the vector sum of displacement of individual waves. So this statement is known as the superposition principle. Again, we repeat it. When a point of a medium comes under the influence of two or more waves, its net resultant displacement is the vector sum of displacement of individual waves. Right? If the two waves are moving in opposite direction, what's happened? They prejudice their nature even after they cross each other. When two waves goes in opposite direction, they prejudice their nature even after cross each other. What it says that if the two waves are moving in opposite direction, like this way, one wave is moving in this direction, at the same time other waves are moving in opposite direction. Both are moving in the same medium. During this motion, the point of the medium at which the both waves are superposed. After cross this So they possess their original nature. Right? So we can explain this thing by the figure. Suppose that is the string, one wave is moving in this direction and other wave is moving in the same string. One wave is moving in this direction, other wave is moving in opposite direction. Now what's happened? When both comes very close to each other like this way. And then they cross each other. So when they superpose, at that time the resultant displacement becomes zero. Because the displacement of these two waves are same and both are going in opposite direction. That is figure A. That is figure B. And C figure. So resultant displacement becomes zero. After they cross each other, so what's happened? The figure is like this way. They possess their original nature even after they cross each other. They cross each other. Clear this? Okay. So that is the figure B. Figure explains the situation of the superposition of two equal waves or the two waves moving in opposite direction. The figure shows the situation of superposition of two waves moving in opposite direction. The resultant displacement of a point or the superpositioning point is zero is shown in figure C. The resultant displacement is zero. It's shown in figure C. It's shown in figure C. So this is the superposition principle. Again, briefly explain or the write and explain the superposition principle. What is the statement? When a point of a medium comes under the influence of two or more waves, its net resultant displacement is the vector sum of displacement of individual waves. So that is the statement of superposition principle. Now, when the two waves moves in opposite direction, they possess their nature even after cross each other. Now that is shown in the figure. Here the one wave is moving in the direction from left to right. At the same time, the same wave is moving in opposite direction, that means right to left. Having the same displacement. So as the time passes, both are going to superpose. When they superpose, at that time, the resultant displacement becomes the zero that is shown in the figure. Because the displacement of the both waves are equal. Right? But both waves are traveling in opposite direction. After they crossing each other, again, they both waves are moving in its direction with the same displacement. Right? So this is the superposition principle. Now next question after the discussion of the superposition principle. Now obtain the resultant wave of two or more than two wave functions by representing the superposition principle. Right? For that purpose, you consider, suppose the y1 xt, y1 at point x and time t, and y2 xt be the displacement of two waves and the net resultant displacement of an element of the string when the two waves are superposed. The net resultant displacement of an element is given by the y at point x and time t is equal to y1 xt plus y2 xt according to the superposition principle. Again, suppose the y1 xt and y2 xt be the displacement of the two waves. Right? The net resultant displacement y xt of an element is given by this equation. Here is okay. Now, if two or more waves are moving in a medium, the resultant for waveform is the vector sum of wave function of individual waves. Now here we are going to derive the mathematical form of superposition principle in form of a waveform. Then first we consider there are two waves and the displacement are y1 and y2. These two waves are superposed at any element of the string. The net displacement of the string or the net displacement of an element of the string is given by y is equal to y1 plus y2 at position x and at time t. Now, if two or more waves are moving in the medium, the resultant waveform is the sum of wave function of individual waves. Now, the waveform of individual waves are, if waveforms, the wave function of individual waves are y1 is equal to f1 x minus vt, y2 is equal to f2 x minus vt, and so on for n, yn is equal to fn x minus vt. X minus v. Therefore, the resultant displacement y is equal to y1. For diagram we can substitute the value of y1, y2, y3, or the y is equal to y1 plus y2 plus so on y. Now we substitute the value of y1, y2 and y from this. So f1 x minus vt plus f2 x minus vt plus so on fn x minus vt. Therefore, we can add in summation form. Y is equal to summation I is equal to 1 up to n fi x minus v. X minus v. There is the resultant displacement of, or there is the wave function of superpositioning of more than two waves, where the I is equal to 1, 2, 3 and n. Right? So resultant displacement obtained y is equal to summation of I is equal to 1 up to n fi x minus vt, where the I is equal to 1, 2, 3 and so n. Right? The phenomena of superposition of two or more waves in a medium is known as the interference. The phenomena of superposition of two or more waves is known as, or that is called the interference. That calls the interference, where the I is equal to 1, 2, 3 and so on. The phenomena of superposition of two or more waves in a medium is called interference. Now listen. Question is there: obtain the wave of more than two wave function by representing the superposition principle. For that purpose, suppose the y1 xt and y2 xt be the displacement of the two waves. There is the displacement of a wave at position x and at time t, and y2 is the displacement of the wave at the same point, same time. The net resultant displacement of an element at which the both waves are superposed is given by the equation y xt is equal to y1 xt plus y2 xt. If the two or more waves are moving in the same medium, the resultant wave form is the sum of wave function of individual waves. Therefore, the wave function of individual waves are y1 is equal to f1 x minus vt, y2 is equal to f2 x minus vt. The similar yn is equal to fn x minus vt. The resultant displacement y is equal to y1 plus y2 plus yn. We substitute the value of displacement in form of a wave function. Therefore, f1 into x minus vt plus f2 x minus vt plus fn x minus vt. Therefore, the y is equal to summation of I is equal to 1 up to n fi into x minus vt. Here the I is equal to 1, 2, 3 and so on up to the numbers of the waves. The phenomena of superposition of two or more waves in the medium is known as interference. Here the two kinds of the interference, constructive and destructive. That can be explained here. If the crest of the one wave is superposed on the crest of the other, or the twirl of one wave is superposed on the twirl of other wave. At that time, the displacement of this particle or this element of the medium is the vector sum of displacement of these two waves. That means it is going to increase. And now, if the crest of the one wave is superposed on the twirl of other wave, or the twirl of one wave is superposed on the crest of the other wave, the displacement is decreased. That means the destructive interference takes place. Clear this? We discuss in next time.